Hello everybody. So today I'm going to prove what you can see on the screen. Now, first of all, we have to say a couple of interesting, important things. We have to say that our A operator is equals to our A negative operator, which and our A uh, cross is equals to our A positive operator. So we can rewrite this as A negative comma A positive is equals to 1. So let's prove it. First of all, we have on our book, that's equation 2.50, that A negative times A positive is equals to a series of things, and what we're most interested in is the negative I over 2h bar and then x comma p. That means that our A positive and then times A negative is going to be equals to a series of things plus I over 2 h bar and then p hat comma x. So let's find this first part that we have. So we actually have solved in the book, and we know it's equals to I h actually I just wrote them, and then we know that this other part instead is going to be equals to, well, I know what is equals to, but let's prove it. So we're going to have what? We're going to have a negative IH bar, and then derivative in terms of x of our function, f of x times x, minus our x times negative IH bar, and then derivative in terms of x of f of x. So we get, I'm going to take out a IH bar out, and I'm gonna get a negative derivative in terms of x, or f of x. So we said plus, because we have negative and negative, plus x, IH, we took out, x, and then, I forgot to write the x over here. X, okay, plus x derivative in terms of x of f of x. Okay, and then we get IH bar, and then here we can use our chain rule, so we're going to have negative x derivative in terms of x of f of x, negative, or minus, f of x derivative in terms of x, which we know is equals to 1, plus x derivative in terms of x of f of x. So we cancel these two. In the end, we get negative IH bar. So that's our equals to. So if we actually use it in our previous formula, so this part over here, we copy and paste it on there, then this is equals to our negative operator times our positive operator minus our positive operator times our negative operator. So this is equals to, well, the first part cancels, and so we'll just get the commutators, and we said that the first part, which I believe is the part solved in the book, yes it is, gives us negative I over 2h bar, and then the commutator of our xp, which we said is equals to I h bar. Then we're going to have minus, again, I over 2h bar, and then we're going to have a negative IH bar, so negative IH bar. So here I'll start canceling out the h bar, h bar, h bar, h bar, and I get, from the first part, I get, we have a I times I, so negative 1 with a negative in front, so it's going to be 1 over 2. And then again, we're going to have an I over I times I, so negative. Did I forget a negative somewhere? Let me check my notes, I'm sorry. I'm actually going to do something. I want to go back step. I want to do something. Actually, I want to cancel out everything. I'm going to cancel out these parts. Okay, so I'm going to do this. This first part was not supposed to be negative, it was supposed to be positive. No, sorry, this was supposed to be negative, and this one was supposed to be positive. So actually, let's have it like this, just easy. H, we said. From the first part, we get 1/2, we said. Then we have I times I, negative 1, with the negative in front, becomes positive 1. So plus 1/2, and that equals to 1. And that is the proof. I hope it's helpful. Please leave in any comments if you have any questions.